So what we're taking a look at is called the standard normal distribution. And this gets used a lot as we go on later. It helps if it's at least close to a normal distribution, that bell-shaped curve as you start with. I believe that number 21 that somebody asked about is very, very close, right? It goes 3, 4, 7, 4, 2, right? It's very close to that bell-shaped curve. Okay. And so what we do is it's basically we come back to the normal distribution because we're kind of lazy. Because once you learn how to use this distribution, it's so easy that you want to come back to this one. And so it's one that we're going to use a lot, so that's why this is such an important day to make sure we can use it, because we are going to come back to it so much. Okay. Sometimes we're going to use it as just an approximation because it's so easy once you get to use it that we don't want to do the other stuff. We just say we're just going to use this one because it's easier. Okay. So a standard score, or sometimes called a z-score, is basically just how many standard deviations are you from the mean. That's really all it means. Okay. How many standard deviations are you from the mean? But what did we learn yesterday? Where is the mean on that bell-shaped curve? It's right in the middle of that thing, isn't it? So do you agree you can go to the right of it and to the left of it? A certain number of standard deviations? And that's why on that little table I just gave you, there's positive z-scores and negative. Either you go to the left of the mean, which is negative, or you go to the right of the mean, which is positive. And how many z-scores did we normally? We wrote out about 3 of them, right? Once you get beyond 3, that's that way out there, right? And look at your tables. Do they go all too far beyond 3? Either way. Not really, do they? They don't go too far past 3 on z-scores, okay? And if you want to find a z-score, it's actually pretty simple. And it actually makes sense once you start doing a couple of these, how you do it. To find and that's how you standardize it. You find the z-score. It goes back to that standard curve where it goes 0, 1, 2, 3, and -1, -2, and -3. No matter what your value is, you can turn it into one of those values, which is kind of nice. And it's actually quite a very simple formula. To find your z, you take that x value, whatever you have, you subtract the mean, and divide by the standard deviation. That'll tell you how many standard deviations over, or to the right or to the left, you should be. Okay? Obviously, hopefully, if your z-score is 0, that means go nowhere, right? So you're at the mean. Right? If your z-score is 1, it means go to the right 1. If your z-score is -2, it means go to the left 2. Okay, you understand where I'm going with those? Okay. And if you want to see a representation of that, that's fine, right? This one here is basically they call it 0, right? That could be anything for you. And then here's your point of inflection, so that's 1, and then 2, and then 3, and you don't really have to go much further than that, right? So if I told you a z-score of 0.5, where are you? To the right of the mean or to the left? Because here's your mean. Right? You're to the right of it, right? Because it's positive. What if I told you -2.7? You're to the left of the mean, right? And what we're really going to start doing is finding the area underneath that curve. That's what we want to do. And your table always goes from the left and fills it in. So if I told you it was a z-score of 1, you're talking about right there, right? And so the area that you would find is all of that. Okay, so those that have had calculus know you can now see how calculus could possibly be used to do some of this stuff. That's integration right there, finding the area underneath that curve. Okay. And some classes are focused that way, but that formula right there is huge. So let's go ahead and see if we can figure this out. So the mean speed of vehicles along a stretch of highway is 56 miles per hour. Notice they don't tell us what the speed limit is. They just say that's how fast the cars are going. Okay? We can make an assumption as to what the speed limit is, but we don't know. They're saying their average speed is 56 miles per hour. Their standard deviation is 4 miles per hour. Okay? So it's very possible that somebody could be going 60 miles an hour, correct? Why is that very possible? Because how many standard deviations away is that? It's only 1, right? The one to the right. And it's very possible somebody could be going 52. Right? Because that's only 1 to the left, right? And so we're going to determine the z-score that corresponds to each of those speeds. So this right here counts as the speed I want to know about, so that's x. Okay? That's the number I want to find out. What's the z-score for that number? Now, let's talk about this just real quickly here. We know that this number in this problem is, what, 56? Do you agree 62 is somewhere over here, right? Agree with that? So let's just make a guess before we actually go calculate it, all right? Let's see how good you are at this. Well, we already know that 60 is actually one standard deviation, right? And then 64 would be the next one, right? So would you agree, these are pretty easy numbers I gave you, right? Do you think it's going to be 1.5? Because, yeah, there's 4 little divisions in there, so, and we're talking about right there, right? Well, let's see if it actually comes out to 1.5. The formula says take your value, subtract the mean. What's the mean? It's 56, and divide by your standard deviation, which is 4. They don't always work out this nice. It'd be great if they did, all right, but they don't. Okay. But the fact that you could tell me 1.5, we're off to an excellent start. Okay. And so, of course, you take 62 minus 56, and you divide it by 4, and surprisingly, we get a z-score of 1.5. Now, does that mean every single problem from here on out, if you see 62, it's 1.5 standard deviations from the mean? No, it could be 10 standard deviations from the mean in some other problem, right? It just happens in this problem, 62 is 1.5 standard deviations from that mean of 56, because the standard deviation is just 4. Okay? So 56. How many standard deviations from the mean is 56? Yeah, none, right? It is at the mean. So there are no standard deviations. So could you actually do the math? Well, sure you could. 56 minus 56 divided by 4 is, well, a z-score of 0. $47. Well, obviously, is this going to be a positive or negative answer? Negative, because it's to the left of that mean, right? And so if I go 1 standard deviation, we're at, what did we say, 52? Right? And if we go another one, we're at, not a trick question, 48. So degree 47 fits in there somewhere, right? Agreed? 47, is actually out a little ways yet, right? So if you had to take a guess, what would you say? It's obviously right out here, right? Negative 2 point something, right? Because it's to the left. And in fact, it's not that hard because the next one is 44, and so 47 is 1 out of the 4, so it's pretty straightforward. But you do 47 minus, that's how it comes negative, right? That's how it becomes negative, over 4. And of course we do that math, and we actually do get a z-score of negative 2.25. Please realize that they don't always come out that nice. All right. And in fact, if you're doing real math, they are just horrible. They're like 4 or 5 decimals long and never get there. But I just want you to get the idea. Some people struggle because they think negative should be to the left of my graph. Because they believe 0, they don't think 0 is here. They think, because that's your mean, they think 0 is over here. Do you see how negative could cause a problem then? All right. But if you know this is your baseline, here's positive, here's negative, it's really not that hard. And it's how many standard deviations away you are from the mean. Okay. Questions on that? Well, I was just going to give you this formula, but I truly believe that we should be able to figure out this formula because it's all based off of this. So here I was saying I'm giving you the x value, tell me the z-score. Now I'm saying here's the z-score, tell me what x value would make that happen. Okay, so we're looking at the same graph, but let's just look at this. In other words, I want to solve this for what? X. Is that something we should be able to do? Yeah, so the first thing we're going to do is we're going to get rid of this, which is sigma, remember, right? And how are we going to get rid of that? We're going to multiply it up, right? So it's z sigma equals x minus mu, right? And to solve for x, what are you going to do? Add mu. So z sigma plus mu equals x. Right? That's how, if I gave you z and you knew mu and sigma, you could be x, right? So again, now I'm going to tell you how many standard deviations it is and tell me what x value or what miles per hour actually gives me that in this example. Okay? I'm going to keep all the other stuff the same. And surprisingly, there it is. Okay? Slightly different form, but same thing, right? It is something you should be able to figure out from that. So I'm going to draw that same graph because I think the graphs are helpful. So we know this is what again for this problem? 56 for this problem, right? And again, we know that out here is what, 60 and 64, right? And what was this way, 52 and 48? I think that's probably enough, right? So now I'm saying 1.6, this is the z value. So it's almost what? almost 2, right? So if you had to take a guess, we're almost going to 2, but not quite, right? So if you had to take a guess at that number, we know it's probably around what? 63 something, right? You know, we know it's somewhere in there. And so, you know, that x then, we go mu, which is 56, plus, well, what z are we using? That one, right? So 1.96, because that's how many standard deviations we want to go. 1.9, not quite 2, but 1.96 standard deviations. And then we put in, what is our actual standard deviation? It's 4, right? That's all you got to do. Type it in, and there you go. You got your x value. And not surprisingly, we were very accurate with our approximation, right? What does it come out to? 63.84, I think I got. So obviously, if I would have started and told you, hey, 63.84, go find the z-score. Well, you would have done that other formula, and you would have found out the z-score was 1.96. That's how many standard deviations it is away in this problem, right? How about negative 2.33? Is the answer going to be 56? No. It's going to be more than 56 or less than 56. Why less? It's negative, right? And negative in this case is going down standard deviations, right? So negative 2, well, this is, probably should use a different color, right? Here's negative 1, right? Here's negative 2, so I'm out over here somewhere, right? And we know that if I go a complete other one, it was at 44, right? So we're talking 40, what do you think, 46-ish somewhere, right? Somewhere in that range, right? Probably not quite that far, right? But somewhere in there, so probably around 47 somewhere. And so let's go ahead, we'll do this one in blue so that we can color code this. And so to find x, we're going to take the mean and add. I normally do add anyways, and then I just put the negative 2.33 here. If you just want to put minus the 2, that's fine. If you understand it that well that you can just put minus, go right ahead, doesn't matter. And then what was it again? 4 standard deviations is what a standard deviation is, right? How close did we get? We did pretty good. 46.68 is what I got, right? So we said 46, 47 somewhere. Does it make sense why it doesn't quite get all the way down to 46? Because that would be negative 2.5 in this case, right? So we knew it had to be a little short of that. That's, again, sometimes where people go the wrong way with which way they do the third. Okay, so that does actually make sense. Now, I'm hoping you can do that next one for me without doing any math at all. What x value corresponds to a z-score of 0 in this problem? It's just the mean, right? A z-score of 0 is just whatever your mean is. Okay, could you go and do that math? Well, of course you could. I mean, you're going to do 56. It'd look like this, right? It'd be 56 plus 0 times 4, right? Because that's your standard deviation, but who cares? It's still 0, right? So it ends up being 56. So imagine my surprise when I was just asking simple questions of the student that called me. And I said, well, if your mean, let's say I asked them this question. I said, if your mean's 56 and your z-score is, and I said your standard deviation is 4 and your z-score is negative 1, you know, what are you looking at? He said, I don't know how to type that in my calculator. Well, that's a huge problem. Because that student really had no clue what was going on. And that was a college class. Is that a question that should have been answered fairly easily? If you know what a z-score is, you know what a standard deviation is, you know what a mean is, 52 should have been a very easy answer for that. Okay? But that wasn't there, and that's a problem. Okay? Do you have any questions on this so far? If you got z-scores, you're going to be all right. Good? All right, let's go use them. Oh, everybody's favorite. The empirical rule, which again is 68, 95, and 99.7, right? Again, the 68 is if you go, yeah, right? 95, and I'll go down if I can. 99.7. So you see how that 0.3% that was left over got divided up between the two tails, right? Got 0.15 each way. Those are somewhat rounded, but they're pretty good for what we're doing. Good enough. Okay, so that's where your 68, 95, 99.7 comes from. But I'm sure that you all can see the bell shape to this curve. And very much so, right? And truly, when it's used in education, they say 68% of you should get a C. This is your B and your D, or either way, it doesn't matter, right? And this is your A's and B's. Okay, or yeah, A's and F's. Okay, B's and D's, C's. Okay. A pluses and didn't do anything. All right, that's how it boils down. Okay, and so if you're asked if you want a bell-shaped curve, then somebody has to get an A, somebody has to get an F. 68% about should get a C. So be careful. It was funny that it was a stats class that the professor asked, do you want a bell-shaped curve on this? And the lowest score was an 82%. And that student said, yeah, sure. And I'm like, you realize that means you fail. And so obviously the professor was testing if we knew that information or not. Okay. So standard normal distribution, very simple. It's normally distributed. Do you get the word normally distributed? It's kind of very symmetric, right? That's what the normal's talking about. With a mean of 0 and a standard deviation of 1. And do you see the 1, 2, 3 at the bottom, and -1, -2, -3? That's what we've been talking about, right? And again, what's the area underneath that curve? Even though it never really touches, it is 1. The area underneath it is 1. The complete area, the whole thing. And make sure you have your tables out because they will soon become helpful. And I'll just use this graph here as an example. What that tells you is from left to right. Once you find a z-score, let's say you had a z-score of 1. What that table tells you is from here, and it shades all of this in. It basically tells you what percent of that 1 you have. It'll give it to you as a decimal. Okay. Obviously, we have a pretty good percentage of it, more than half, correct? Because where does half of it actually come in? At 0, right? At the mean is 50%, right? We have more than 50%. We don't have 90-some%, right? So easiest way is probably just to subtract the ones we don't have or add up the ones we do have. Okay, but that's basically what that table does for you. No need for you to do anything. It'll just tell you what it is. All you have to do is find it on the table. So, z-score of 1.15. So I told you z-scores aren't always nice, right? Again, that means 1.1 standard deviations, right? So where does that kind of fall in? Well, we know that this one here corresponds to 0, right? We know that's 1. We know this is -1. So which way are we going here? We're going to the right. Agreed? So can you give me maybe just a guess that we know more than half or less than half? Because remember, we're talking about this. All of this is what it's going to tell you. We know this answer is more than half, right? Okay. In fact, we know it's more than 68%. How do we know that? Yeah, we would have at least both of those 34s in, right? We went past 1. And 1 each way is 34 each way. So we know we have even more than that. Okay, so we're doing pretty good. And here's how we're going to actually calculate it. You got to find your z-score. So obviously you're on the side that's positive, right? So you start by finding your z-score of 1. Okay, 0.1. And then now I have to find the 5. So you see how this 5 over here, or these numbers at the top kind of fill in that last digit for you? Because it goes to the hundredths. This goes to tenths. So you find 1.1. So we know that we're going to look at this one somehow, right? And then we need to say 1.15. So you go out here. Do you agree that if I find the intersection of those two, that should be where 1.15 is, right? And does that answer make sense? It's basically saying 87% of that little normal distribution there has been shaded in. Do you agree with that? Yeah, definitely, right? That's believable. Okay? And so that is your actual answer. It's 0.87. It's right here, right? For some reason, I can't just read the numbers and write them down. I don't know why. So in other words, 87% of that little curve has been shaded in. Pretty nifty. It didn't really take much work, right? The table just gave you the answer. Okay. And what's going to happen is that's going to start corresponding to a probability here soon enough. So that'll be nice. Okay. So what else we got here? How about 0.405? Now I'm saying, I'll read the question. It says determine the z-score that corresponds to a cumulative area of about 40.5%. You see that? So we know 0 is here. Let's see if you can tell me about where that would be. Because it's going to help you, because that table's big, right? If you don't know where to start at all, you're going to be searching forever. So there's 0. what is it if I shade everything to the left of here? That's how much? That's 50%, right? That'd be 0.5. This is 0.4 is the area we're talking about. So I'm definitely going to be a z-score that is positive or negative. Has to be negative, right? Do we really know how far? Not perfectly, right? But at least we know which side of our paper to be on, right? So then you go and you look at your negatives, right? And I chose between negative, well, I chose between basically 0 and negative half, okay? Because I knew that if I went 1 standard deviation, that was a pretty big change, right? If I went 1 full standard deviation, that would be a change of 34%. So I knew, you know, it's not that far, right? Because it's pretty close. It's within 10%, right? So I stayed pretty close. Does that make sense what I just said? That 1 would be 34%, and I knew it was within about 10% because that's 40.5%. Okay. So I knew I was close, and so then you got to just find that number on here somewhere. And I think the best we're going to do, right there. Is that the best we can do? Yep. And so what is the z-score that corresponds? Negative 0.24. And again, does that make sense that negative 1/4 of a standard deviation would have gotten me over and given me about 40%? Yeah, because that's saying about here maybe, right? That's 1/4 of that standard deviation. Does that seem to be about 40%? Yeah. Mm-hmm. Because I looked at the area. Remember, this is cumulative area. I knew a z-score of 0 gave me 50% of the data, which would be 0.5. You see right here? Okay. And so I knew if I had less than half of the area, I had to be to the left of the mean. Anything more than half has to be to the right. Okay. Any questions on that? All right. Here's where things can get interesting. But it's really not all that much harder. So what if you need the area to the right of your z-score? Or they give you 2 z-scores and say find the area in between. Well, that could get a little more difficult. Well, let's just do this one. It says the area to the left of z being negative 0.99. That's really close to what? Negative 1, right? It's very close, right? And so this one, so here's 0, here's negative 1, right? And so we're saying basically right here, and I just want to the left. Will the table tell me that? Can I just look that up in the table and use that answer? Yep, because the table does left up to your point. It always does from the left over. Okay. There are some tables that do it differently, but you don't need all those other tables. We have all the information we need in one table. Okay. And so what you do is you go find that z-score. Okay, so obviously you're on the negative side, right? So negative 0.99. So in other words, which number on here, it's pretty easy to describe to me which number I should be looking at. And this mine, being negative 0.99, and so basically the top right of my little table here, right? The one that I have. So negative 0.99 is that number. Right? So 0.16109, or you could say that percent. Is that believable? Only 16% of this curve is shaded? Yeah, I think it is, right? That's believable. And even if you look back, one other way you could have gotten really close to this answer is just looking back to this. Right? I mean, this was going to get you darn close if you just added these up that were to the left, right? You were going to get in a reasonable number. How about a z-score of 1 point to the right of 1.06? Well, let's find out where that is. Do you agree that's right here? Right? But what I really want is that. A couple ways you can do it. And I want you to be careful. Okay? Can you? Well, we'll test that theory in a second. Here's what I want you to learn how to be able to do. Let's go find the answer the table gives us, which is this, right? Let's do 1 minus that. right? Do you agree I have the complement of the blue? That's what I want. So let's go find the answer the table gives us. And then we'll test your hypothesis as to whether I can do it the other way. So we've got 1.06. So that would be right there, right? 1.06. So it's 0.85543, agreed? But that's the blue. I want the red. Take 1 minus that. And we get 0.14457. Is that what you said? Is that believable? Yeah, 14%. Right? A little less than the one we just had, which is believable because it's further out, right? Now, what was your other strategy? Unfortunately, I don't think I'm going to have that on here. So you're saying find negative 1.06 and just find that. Should that work? Isn't it going to be symmetric? It should be, right? Let's. What color can I use here? Green. So negative 1.06 you're saying is right here, and should that area I just did in green be the same as the area we have in red? Should, right? It is symmetric. That's the whole idea of the normal distribution, that it is symmetric over that mean. Left, right, same, right? And so yeah, you can go ahead and just do that, as long as you feel comfortable using that table, and it does come out the same, correct? I mean, I think maybe it doesn't go out that far for decimals, or does it? It does, right? Oh, okay. And does it come out? Is it exactly the same? Oh, excellent. Good. Sometimes with rounding in the tables, it gets a little off at the ends, but so there you go. Very clever. Now what? You could. I think that might be confusing for some people, though. But I know exactly what you're saying. Let's draw the picture first. So 1.25. So again, this is 0. That's the hardest thing. If you got that down, you've got this thing about half completely in your head. You're almost done, right? You know that's 0. And here's 1 standard deviation. So we're talking about that as 1 point. Well, it's probably a little further, right? You get the idea. And negative 1.5. It wants that. Agreed? We know that it's more than 68, right? And we know it's definitely less than 95. So that's not a very good range. We should probably narrow that down a little bit. So one way you can do it is basically just find everything to the left of this and then just subtract out the stuff you don't want. Are those two things I can find in the table fairly quickly? Yeah, to find the red that I just shaded in, just take that z-score, find the answer. To find the stuff we don't want, which I'll do in green, all we have to do is find that answer and subtract it, right? You agree with that? You see how that logic is coming out of there? Just subtract it off, okay? And notice I chose 2 different z-scores so that it wasn't just symmetric and would be really easy, right? And so let's find those. All right, what do we got here? I think I got them both in here. So what do I have here first? Oh, the negative I have first for some reason. So negative 1.50, right, is this one. So there's the answer. Oh, I should have color-coded that, sorry. Negative 1.5, and then we got positive 1.25. Right there. So in other words, you need to take 0.89435 and subtract 0.06681. Is it surprising that this is so small? 6% for negative 1.5? No, not really. That's pretty tiny over there, right? And this one's so big, 89%? Yeah, that makes sense, right? So you go ahead and you subtract those. So you take 0.8943. That is a 5, right? I kind of wrote over it. Yep. And then minus 0.06681. You subtract that, and magically you get to the answer of 0.827. What's it come out to be? 0.825. Yep, 54. So in other words, translated means 82.754% of that entire area. Okay? So you might even be able to start seeing how this is just going to start becoming probability, because every time it's how much you have over the entire thing, but the entire thing happens to very coincidentally be an area of 1. And dividing by 1 is so much nicer than dividing by anything else. Okay? So that percentage is just going to end up being your probability. No more work needed. So do you see how nice this is? It just gives you the answer, basically. And that's why we're going to take stuff that's not normally distributed, and we're going to try and work it towards something that is, so we can do this. Okay, and what's going to make it dependent on that is how big is our sample. Okay, if your sample's big enough, you can do this. And you don't have to worry about it. Okay? And that's what a lot of statistics is. I don't even know what, oh, this is nothing. Okay. So just an extra page, apparently. So any questions on that?